Sound in Medicine. Ultrasound Applications. By Assistant Professor of Medical Physics, Dr. Al-Arif. Production and detection of ultrasound. Ultrasound is produced and detected using small device called transducer. The transducers, see the figure, capable to send pulse of ultrasound and to detect the reflected back pulse and convert them to electrical signal. Transducer contain a piezoelectric crystal grows and shrinks depending on the voltage run across it. When alternating current pass through the crystal, it vibrates strongly producing ultrasound pulse. The pulse moves forward then reflected back off the object under investigation. The reflected pulse hits back the piezoelectric crystal causing a mechanical vibration energy to develop which is converted to electrical signal sent to the attached computer for analysis. By measuring the time elapsed between sending and receiving the ultrasound pulse signal, the computer can determine the depth of the object and to display the received signal as a peak or dot on the monitor. Frequencies used in diagnostic procedures. In general, ultrasound uses high-frequency sounds above 20,000 Hz. Ultrasound can't detect objects that are smaller than its wavelength and therefore higher frequencies, lower wavelength, of ultrasound produce better resolution for smaller objects. Higher frequencies ultrasound are used for scanning surface areas of the body while lower frequencies are used for deep diagnoses since the penetration power inversely proportional with frequency. Frequencies in the range between 1 to 50 MHz are usually used for different diagnoses procedures. Doppler effect to measure blood flow. When the ultrasound source and the observer are moving toward each other, the observer hears a higher frequency wave. Also, when the source and the observer are moving away from each other, the observer hears a lower frequency wave, as in the figure. To measure blood flow in an artery, a series of pulses is transmitted into the suspected area to detect the motion of blood cells. Echoes received back from moving blood cells exhibit slight differences in frequencies. The difference in frequency received is measured as a Doppler frequency shift, F sub d. This information helps to measure the velocity of moving blood cells, v, in an artery using specific mathematical formula. If speed increased the normal value, this indicate the presence of blood obstruction at that place. The following equation is used by the computer to find the velocity of blood. In practice, the transducer is placed at certain angle over the body and a sweep to the area must be carried out while sending the ultrasound pulses. Ultrasound therapy. Ultrasound can also used in therapy. Mechanical energy of the ultrasonic wave is converted to heat. It is possible to heat selected parts of the body more efficiently using ultrasound. This type of treatment, called diathermy, and is used to relieve pain and healing of injuries. Ultrasound with high intensity can also destroy tissue. The change in pressure that produced by ultrasound inside the body can destroy tissue. The negative pressure can force the dissolved air or gases to produce a big gas bubble that can pushes and destroy tissues or organs by a process called cavitation. Ultrasound is now routinely used to destroy kidney and gallstones. Lithography. Ultrasound diagnostic modes. The A scans. A scans can be used to measure distances or depth of objects inside the body. The transducer placed over the body emits an ultrasonic pulse and the time taken for the pulse to bounce off an object displayed as a peak and graphed in order to determine how deep is the object from the surface. A scans only give one-dimensional information and therefore are not useful for imaging, biometry measurements only. The B scan, two-dimensional scan. Composed of two types of motions, a horizontal movement over the body, sweeping. Rocking movement at different angles. It is used to take a cross-sectional image through the body. The transducer is swept across the area and the time taken for pulses to return is used to determine distances, which are plotted as a series of dots on the image. B scans will give two-dimensional information about the objects, see the figure. The M mode, motion mode. As in the figure, the movement of structures at different time intervals while moving can be detected and displayed. Initially a 2D image is acquired and a single scan is done along the area of interest. The M mode will then show how the structure moves toward or away from the ultrasound probe with respect to time.